In this video, we are going to learn Hussey diagram. It is a very useful tool and it completely describes the associated partial ordering. This is the systematic diagram of representing a poset. So we have learned what is a poset, right? So Hussey diagram is nothing but representing poset in a diagram. So how to represent it as a diagram? In this diagram, the elements of the posets are represented by means of dots. So elements are represented by means of dots. Okay. Then if A and B are two elements of A, capital A, and if A less than or equal to B, then there is a line segment joining the dots representing A and B. So if A and B are two elements of A, so you have capital A, that is the main set. If you take any two elements A and B, and if A is less than or equal to B, that is A is less than or equal to B, then there is a line segment joining the dots A and B. We can join A and B. The self loops are not shown, so no need to draw loop here. Only a line segment is drawn if it satisfies the property A less than or equal to B. And also, if A less than or equal to B and B less than or equal to C, then there is no line segment from the dot A to C. So suppose you may have conditions like this, right? A less than or equal to B means you can join A to B. B less than or equal to C means you can join B to C. But no need to join A to C. Okay? That's what mentioned here. There is no line segment from the dot A to C. But there is line segment from A to B and from B to C. If this condition satisfies, you can draw a line from A to B and B to C. Such a graphical representation is called of a poset is called a Hussey diagram. Such a graphical representation of a poset is called a Hussey diagram. Yeah, students, we'll learn a question now. Let P is equal to set 1, 2, 3, 4. Draw the Hussey diagram for the poset P less than or equal to, where less than or equal to is the normal less than or equal to. So while doing this problem, you will understand more. Okay. So what we are going to do is, we have to start with the highest number. Let me take 4 now. 4 is represented by dot. So all the elements are represented by dots. Okay. So I take 4 here. And what about the relation? It is less than or equal to. And it's nothing, it is normal less than or equal to. It is given like that. So we will take 3. What about 3? 3 is actually less than 4, right? So we can mark it in the next step. That is the step down. You can step down here. This is 3. And you see, actually 3 is less than 4. So you can connect it using a line. You can draw a line here. Then next number is 2. So you can represent 2 using a dot. And we know 2 is less than 3. So here also you can connect by a line. So then only one number. You have one more element, that is 1. You can take 1 the next step, and 1 is less than 2. So you can draw a line. So you will be getting a line like this. You can make it as a straight line. Okay, you can make it as a straight line. So here all these points, elements are represented by dots, and the relation is represented by the straight line. As we have learned, 2 is less than 4. No need to draw a line from 2 to 4. Okay, 1 is less than 4. No need to draw a line from 1 to 4. Just you can compare the number, that is that means the next number here. 3 is less than 4. It is enough. You draw a line. Then 2 means no need to draw 2 and 4. It's just 2 to 3. Then 1 to 2. This gives the Hussey diagram to this particular question. Okay, next question. Let P is equal to 2, 3, 6, 12, 24, 36. Draw the Hussey diagram for the poset P, S. The relation less than or, this is less than or equal to, okay. the relation less than or equal to, this is also less than or equal to, be such that x less than or equal to y if x divides y. So here less than or equal to stands for x divides y. Okay, x divides y. So let us verify this, or let us draw the Hussey diagram. First take the largest number, 36. So I take 36 and next number is 24. So whether 24 divides 36, here what about the relation? Less than or equal to, and what does it denote? It denotes x divides y. Whether 24 divides 36, it does not, divides means remainder should be 0, right? But here when you divide 24 by 36, the remainder is not 0. It does not divide. So no need to take in the next step. We can use this method. That is, you put a dot here and you draw 24. You can mark 24 here. Now let us take the next number, that is 12. Whether 12 divides 36 or 24, 12 divides, 12 3s are 36, 12 2s are 24. Yes, it divides. So you can take 12, maybe in this side, or anyway in the next step we can take, because it satisfies the condition. So I am taking it in the middle because it divides both the number. So after that you can connect like this, like this. Okay, because 12 divides 36, 12 divides 24. Now next number is 6. 6, next step, 6 divides 12. So you have to take here 6 divides 12, right? 6 2s are 12. So you can take 6. If 6 does not divide, you can plot 6 somewhere in the same step. Okay, here it divides, so we take in the next step, and divides, therefore we connect it. Okay, fine. Now next step, 3. Whether 3 divides 6? Yes, it divides. So we can write 3 either here, okay. But if you take 3 here, what about 2? 2 does, after 3 we have 2, right? If I take 3 here, after that 2 does not divide. Anyway, I have to take 2 somewhere here, because 2 does not divide 3. So what I do is, I take 3, let me take 3 here. Okay, in the next step, I take 3 and I can connect it, because 3 divides. 3 divides 6, so I can draw a line. Then we have 2. Okay, then we have 2. And if I take 2 here, 2 does not divide. So I have to take 2 in the same step. 2 does not divide because 3 divided by 2, 1 2 is 2, remainder is 1. So it does not divide. So I take in the same step. But 2, you compare with the previous step. 2 3s are 6. It divides 6. So you can connect like this. Okay. So this is how you draw the Hussey diagram. If it divides, you can move to the next step. If it does not divide, you can take the point in the same step and you can connect it like this. And this gives the Hussey diagram for the given set, and the relation here is x divides y. It is denoted as less than or equal to, but actually less than or equal to is defined here. It is x divides y. So this gives the Hussey diagram. And here you see, draw the Hussey diagram for less than or equal to relation on this set. So here less than or equal to means normal less than or equal to, because it is not specified here. Okay. So you have to start with the highest number, 15. Then 11. 11 is less than 15. So you can connect it. 10, next step, 10 is less than 11, 5 is less than 10, 2 is less than 5, 0 is less than 2. So you can connect like this. This gives the Hussey diagram for the given question. And here is the next question. Draw the Hussey diagram for P equal to A comma B. A divides B. Here also, as we did in the previous, means we did a question like divides. So we can use that here. Divides. That is, okay, the first number is 12. So we can take 12. Then 8. Whether 8 divides, right? Whether 8 divides 12? No. So we have to take that point the same step. You can write here. And you come to 6. 6 divides, yes, 6 divides 12. So you can take 6 the next step. And you can connect 6 and 12. And then the next point is 4. 4 does not divide 6. So you can take 4 in the same step. And you can connect 4 divides 8 and 4 divides 12. Right? 4 divides 8 and 12. So you can join the lines. Now 3 divides 6. So you can take 3 and here 3 divides 6. Then next term is 2. What about 2? 2 does not divide 3, but here 2 divides 4. 2 divides 4 and 2 divides 6. Then next step 1. 1 divides both. 1 divides all the number, right? So 1 divides 3 and 1 divides 2. So this gives the Hasse diagram for the given question. Here we have some questions, okay? So here you see, draw the Hasse diagram for the following question. P of a subset where a is equal to xy. So what are the subset of xy? Subset of this is, you can take singleton x, singleton y, then xy itself is a subset, and empty set is also a subset. Okay, so likewise we have 4 subsets. You can start with the biggest one, x comma y. Then you take, after the biggest you can take either x or y. If I take x, yes, x is subset of xy, so you can connect. Y, you cannot take y because in the next step y is not subset of x, but y is subset of xy, so you can take y here, and y is subset of xy. You can draw a line. Then one more set, 5. 5. Empty set is subset of every set. Empty set is subset of every set, so you can connect x and y. So this gives the solution to the first question. Okay. Second question, 1, 2, 3. So write all the subset. Empty set is a subset. 1, 2, 3. All the singleton set. Then 1, 2, 2, 3, 3, 1. Then 1, 2, 3. So these are the subset. Now drawing the Hasse diagram, you have to start with 1, 2, 3. Then after this you can take 1, 2, 2, 3, 3, 1, right? So you can take 1, 2, then you can take 2, 3. Okay, I take 1, 3, then 2, 3. And you see 1, 2 is subset of this one, this is subset of this one, and this is also subset of 1, 2, 3. Now below this you can take, what is that, set 1, 2, 3 is there. So you have to take set 1, set 2 and set 3. Yes, 1 is subset of this and also 1 is subset of this one. 2 is subset of this one, 1 and 2. 2 is subset of 2, 3. 3 is subset of 1, 3. 3 is subset of 2, 3. So you have to connect all those elements. Now you have empty set 5. So if you take empty set 5, 5 is subset of 1, 5 is subset of 2, 5 is subset of 3. So you get the Hasse diagram like this. Okay. Yes, next question you can you can do on your own. Okay. First you have to write D30, that is numbers that divides 30. 1 divides, 2 divides, 3 divides, 5 divides. So these numbers divides 30. So all the set of all factors of 30 should be here. Then you can start drawing. So while drawing, first you have to start with 30. Okay. Okay students, you try this on your own. Okay, ordered pair is not needed. If you want, you can write last. It's not necessary. You start with 30. 10 divides 30. You can draw a line. Then 6 does not divide 10, so it draws 30. Then 15, it does not divide 10, it divides 30. Likewise, you try to complete this and you verify whether you get a diagram of this form. We have done enough using divisibility, right? So you can use that. The thing is, D30 means divisors of factors of 30. So you have to write all the factors of 30. 1, 2, 3, 5, 6, 10, 15, 30. Then after that you can use divides, and we have learned earlier, we did so many problems. Try this on your own. Okay.